And then Adam has a homework question.
I'm sorry. I didn't want to write.
I know, but you have 20.
Well, maybe Noel, if you were here on time, you would have.
I have to.
I will take a minute and find it after I'm done here. Oh, right here, you're lucky it's on time.
First time teacher ever to shave.
Now, any question about the quiz? Did anybody miss something that you're not sure about why you missed it?
Can we do the bonus one?
2B.
What was your bonus? How do we find a unit vector? That's easy. U has coordinates 1, 4. Who remembers how to find a unit vector? Well, the length is 1. Cody, get your head up, please. We're finding a... Is he asleep?
Yes,
Wake him up.
I tried. He won't.
Yes, he will. You need to wake up, get your head up.
I don't want to
Next
wake up.
time, I'll just dump this bottle of water right on your head.
Oh! I will videotape it and send it to the
Okay.
office.
Now, to find the unit vector, we simply take the coordinates of the vector and divide by its magnitude. So what is the magnitude of the vector 1, 4? Root 17. So we're just going to put both of these over root 17, and that's the answer to the question. That's all there is to it. That's all there is to it. Okay? All right, Adam, you had a question?
On homework, I did.
Yep. What was your question?
45A.
All right, so we are looking in section 6.1, and we're doing 45A, which involves shooting a basketball. It says a basketball is shot at a 70 degree angle with the horizontal. So here's the horizontal. This board is so dirty. So we have a 70 degree angle with the horizontal. So that would look like this. And the speed of the ball is 10. Speed is the same as magnitude. Okay? Now, what do I want to know? What does the question ask me for?
The other side. Or no.
What does it say literally?
Oh, I just have the
Okay,
problem.
where's your book?
I don't have it with me.
Can somebody tell me what it says? I can, because I have my book open and I read the problem. It says find the components of the vector. The components of the vector are x and y. Okay? So how do we find x?
Cosine, sine and cosine.
So we'll say cosine 70 equals x over 10. So x equals 10 cosine 70. And sine 70 equals y over 10. So 10 sine 70 equals y. I type that into my calculator and I write it as a nice little vector. Those would be the components right there, the x and the y, that you get when you type those into your calculator. Okay? Vector components are nothing more than x and y. And we find x and y by drawing a picture and doing our SOHCAHTOA trigonometry. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. Right? All right, get out your packets, because today we're going to learn a couple of new things. Tomorrow we'll have a quiz over this, so you'll want to be paying close attention.
Like last night's homework?
No, a quiz over what we learned today. And it's pretty easy. We're on the back side of page 50, where it says 6.2. At the end of the period, we'll do a practice quiz. But let's pay attention now so we can learn what we're supposed to be learning. Noelle, you didn't, I gotta give you detention for this, but now you're chewing gum again. Okay, so you need to bring in your box of Kleenex tomorrow. We're back to one box because you're getting a detention for this. So you're bringing your one box. Okay, and get rid of the gum. We're going to find the dot product. This is called the dot product. Robbie, you want to remove your hood, please? V dot U, and that's the way we say it. We say V dot U. To find the dot product, here's what I'm going to do. I'm going to show you what the answer is, and I'm going to see if you can figure out how I did it. The dot product of these two vectors would be 1 times 2 plus negative 2 times 3. So the answer is simply negative 4. So what is the procedure for finding the dot product?
Multiply x and y and then add the products together.
What she said. Multiplying both the x's and adding them together.
Exactly. Multiply x times x, multiply y times y, and add them together. It isn't hard at all. It's like we did when we multiplied matrices. Take the first numbers times each other, the second numbers times each other, and add them up. So looking at number 2, or B, letter B, what would be the dot product of negative 1, 6, and 3, 1?
First thing we got to do is multiply that 2.
Negative 3 plus 6
We're on
is
6.2, question B.
3. It's 3.
I'm on the wrong thing.
The answer is 3.
So we're going to have negative 1 times 3 and 6 times 1. Negative 3 plus 6, the answer is 3. Go ahead and do C on your own. Tell me what you get when you do C on your own. I hear a negative 2. Robbie, what's on your side?
Nothing. Wait, what was I supposed to say?
The dot product in problem number C is negative 2.
Bam.
What is it in D?
24.
24. On tomorrow's quiz, there will be a dot product question.
Of course.
I am going to give you 2 vectors and say, find the dot product. You take x times x, y times y, add them together, the answer would be 2. Everybody clear? All right, step 2 of today's lesson. We are going to find the angle formed by 2 vectors. Now, this is very, very simple, but I want you to remember a little formula. The little formula says that the dot product, which you now know how to find,
Yeah, we do.
is the magnitude of the first vector times the magnitude of the second vector, and we know how to find magnitude, times the cosine of the angle between them. So dot product equals magnitude times cosine. So let's see how this works. Look at problem 2a. It gives me the vectors negative 3, 1 and 1, 2. And I'm going to find the angle between them. So according to my little formula, what's the first thing I want to find?
Magnitude.
Well, I definitely want to find magnitude. I also want to find dot product, which I know how to find. What is the dot product of these two vectors? Negative 1. Once again, how do we find out product? First times first, second times second, add them up. Negative 3 plus 2, negative 1. Got it, Potter? Okay. Now, what does dot product equal? Magnitude of the first vector. Okay, let's draw a picture of this. Over 3 up 1. Over 3 up 1. What's his magnitude? Root 10. Times magnitude of this one. Over 1 up 2. What's his magnitude? Root 5. Times the cosine of the angle between them, which is what I'm looking for. I have no idea what it is. I'm using theta. Don't, if that confuses you, use X or A or something. That's what I'm looking for. I need to find that angle. Now, these two can be times. So negative 1 equals root 50 cosine theta. Any idea what I might do next? Divide by root 50. Now, how do I get the angle? Remember on your calculator, in order to get the angle on your calculator, you have to second cosine, right? Please don't lean the desk back. So second cosine, negative 1 divided by the square root of 50. I got 98.13. Anybody match that?
Yes.
And that is the answer to the question. Remember, the question was, find the angle between these two vectors. So the little formula I ask you to use is dot product equals magnitude times cosine. So we found our dot product, we found our magnitudes. I multiplied the magnitudes together, divided, and then in order to find an angle on my calculator, I always second something. In this case, it's second cosine. So I second cosine, they got 98.13. Meredith Stewart, will match.
Never mind.
All right?
Another one?
Yep, we're going to do all of these. So here we go. Next one says, my vectors are 3, 2, and 5, 4. Okay, gang. Step 1, remember our formula. Dot product equals magnitude times cosine.
What product is 20?
Okay, Cody,
What I do?
I want you to go to the office and you can just go, you can just sleep in the sick room. There's no point in you sitting in my class and sleeping. I find it offensive, disrespectful, and every other adjective you want to use. So we're just not gonna mess with it. No, I'm emailing him, telling him you're on the way.
St. Patrick's Day's Creed. Did she know that? Sarah here, let me sit back. I think pictures of it, it's on.
Bye, Cody.
All right, Cody.
All right, Cody. See you later.
Okay. All right, so we're doing this, we're finding the angle between these two vectors. So here we go. Dot product, you've already figured it out. It's 15 plus 8. Did you say 23?
Yeah.
So the dot product is 23. Remember our formula. Dot product equals magnitude times cosine. So here's my dot product. Now I need the magnitude.
Root 13.
So I'm going to draw a picture of it. Some of you can do this in your head. Some of you need to draw the picture. Over 3 up 2, Pythagorean theorem would say 9 plus 4? Root 13. First times first, second times second, add them up.
Oh, okay.
Dot product. Now, I draw a picture of the second one, 5, 4. That magnitude would be 25 plus 16. That's root 41. Now, before, in the last example, these numbers were easy enough, I could just multiply them in my head. 13 times 41 is 533. So I'm going to put those together and say, okay, I have the square root of 533 cosine theta.
It might be a silly question. I mean, the 13 and the 41, because they're both under the radical, you just multiply them together? Okay.
No questions.
Questions?
Now what do? I divide. So I have 23 over root 533 equal to the cosine. How do I get my angle?
Second cosine.
Second cosine. So second cosine, 23 over root 533.
They just want you to be basically.
And what do we get?
4.97.
I'll take your word for it. 4.97?
EH.
Tiny little angle. What's our formula that helps us find the angle between two vectors? Dot product equals magnitude times cosine. Okay? Let's look at the next one.
So funny.
C.
Is that what you're in?
I saw it this morning. I literally laughed out loud.
Do not say.
It's the same thing as earlier, it's just in a different format.
Yes, exactly. Problem C is exactly the same question, but instead of writing out the coordinates, I do a picture. Your vectors are 2, -3, and 6, 4. And we want to find the angle between them, the angle that they form. We want to find that angle. So here we go. What do I do first?
It's 0.
It's
Dot product. Oh, the dot product is 0?
Yeah.
Can that be?
Can that be? It absolutely can be. Something special is going to happen. So here we go. Magnitude of the first vector, root 13.
Hey, my brother.
Magnitude of the second vector,
That's not a thing.
what is that?
Oh, did you go on a retreat?
36
Oh,
plus.
is that a real retreat, girl?
52?
Yeah.
Yes, ma'am. I have no.
Square root of 676.
676.
Thank you.
What's the next step?
Divide both sides.
Divide, but that's just still going to be 0, right?
0 equals 676. I mean, cosine of.
So
The answer
what
is 0.
angle has a cosine of 0?
0.
Oh, 180. 180.
Do it on your calculator. Second cosine 0.
90.
9.
90.
All right.
Okay, now wait a minute.
I don't know.
That means the angle formed by these two vectors is 90 degrees. So tell me about those two vectors if they make a 90-degree angle. They're perpendicular. But in vector land, we don't say perpendicular. In vector land, we say orthogonal.
That's a weird word.
So in vector land, orthogonal means perpendicular.
I think we should open up and be part of the whole vector land.
Now,
All maps out.
keep in mind, this isn't the first time we had a new word. We don't call a vector's length its length, we call it magnitude. We don't call a sum, we call it a resultant. We don't call a coefficient, we call it a scalar. So there's lots of new words. This is just another one.
When the dot product equals 0, does it help to assume that it's going to be perfect?
It isn't an assumption. Listen to what Noel said. If the dot product is 0, then V will always be orthogonal to
So it
U.
saves you all that time?
Always.
Okay.
If you do the dot product and you get 0, then you know the vectors are perpendicular to
And
each
the
other.
answer is,
She asked, okay, when will this next test be?
Friday,
so
yes.
the answer is orthogonal.
No, the answer is 90 degrees. You're finding the angle between the vectors. So that's 90 degrees.
So is it safe to assume that every single time the dot production equals 0 is going to be 90 degrees?
Yep.
Sweet, right?
Good.
Okay. One more.
What?
I'm so glad nobody heard what you said.
Makoni, pay attention.
Your thing is to
I need my dot product.
dot product. That's
So I need my dot product.
It's not a thing.
Add them up.
Hey, guys, enough. Hey, put your feet on the floor.
I don't know.
Now, dot product, x times x, y times y, add them up. Right? Now, what do I do with the dot product? It's equal to
The magnitude.
magnitude of the first, which is the square root of 20, times the magnitude of the second, which is the square root of 29. Nope, I wouldn't simplify anything, because it's easier to leave them together, because I'm going to
Square root of
multiply.
580.
Wow, I don't hear
And then I'll divide. And when I second cosine that,
I can't be in some.
oops, 85.24.
Yes, ma'am.
Makoni, I need you to turn around and I need Clark and Penuto to shut up. All right? We're all paying attention.
I haven't really said.
All right, so 85.24, got it?
Yeah.
One more task. Turn the page. Now your job is to take a couple of vectors and determine their relationship to each other. Are they parallel, perpendicular, or neither? Okay? Now, there are different ways to do this, but one way that's real easy and you already, I hope, are comfortable with is the idea of using slope. For example, when I look at the first vector, 2, 1, Timmy?
Yeah.
You're up here.
Sweet.
When I look at the first vector, which is 2, 1, if I think about drawing that, it's over 2, up 1. tell me about the slope of that vector. If it went over 2 and up 1, its slope is 1/2. Boys and girls, slope is y over x. Rise over run. So it went up 1 and over 2, so its slope is 1/2. Y over x. What about this one?
It's -1.
It goes left 2, up 4. Rise over run.
-1/2.
4 over -2, that would be -2. It's y over x. Y over x.
They're perpendicular.
These two are opposite reciprocals, aren't they?
Yes.
This is 2 over 1. Opposite reciprocal slopes mean they are orthogonal to each other. Now, you could also have done the dot product. What's the dot product of these two? 0. And we just said if the dot product is 0, the vectors are orthogonal. Either way, makes no difference. Now, let's look at the next one.
It's parallel.
We have 2, 1, and 6, 3.
Oh my God.
Okay, so the slope
I can't do it.
What's the slope? The slope for all of them.
1/2
What's the slope here is 1/2,
and
1/2.
3/6.
3, 6.
1/2.
Now,
So
what
zero.
do you know when the slopes are equal? Parallel. These are parallel because their slopes are equal. Meredith.
Okay, so if you do the dot product for this one, I don't understand how you can determine which one it is.
All you can do is tell it's not perpendicular. It doesn't help you with the other stuff.
So we need to get the slope. What you're trying to say.
Slope is a good thing.
Slope.
Okay, next one. 2, 1, and -5, 7. All right, tell me about this slope. This is 2 1s.
1/2.
1/2. Tell me about this slope.
7 over -5.
-7/5.
Neither.
Neither. They're not parallel and they're not orthogonal. They are nothing. All right, on your own, do D. Do D. Uh-huh.
Is that
Do
also
number
neither?
D right now, Paconi.
Is that also neither?
You bet the bottom to this.
What?
What'd you get?
Neither.
Neither. Everybody okay with neither as an answer? All right, let's try D.
Parallel.
Let everybody catch up.
Parallel.
Parallel.
Robbie, where is your packet?
We move on to F.
You're so far up there.
Yes, you can go on to F. What did you get for E? Did you get parallel?
Yes, ma'am.
Okay. And F is orthogonal.
Perpendicular.
And it's orthogonal because
It's -1/3 versus.
the slope of the first one is -3,
Ortho.
and the second one is positive
Orthogon.
3.
Orthogon.
-1/3 and positive 3.
Orthogonal, is that what it
Okay.
is?
Now, I would like you to find a scrap piece of paper. We're going to take a practice quiz.
All right.
And then you can do your homework.
Miss Ford, can I use the back of my homework?
Yep. You
Heck
absolutely
yeah.
can use the back of your homework.
Heck yeah.
Yeah, no, did Robbie do it?
Wait,
Adam, you did the homework?
Yeah, I did. Robbie did it. Neither did Julia. That's always my homework. I'm sorry.
All right, here we go. Here we go. Practice quiz.
Right, oh, God.
I'm a savage. Wait till she turn around.
give this a shot. This is your practice quiz. So we're gonna do this. And when you are done with the quiz, if you feel like you can do one of the problems and want to put it up so we have the answer, that would be great.
Oh, I got it.
Are you done with the quiz?
Yeah.
You've done it all.
Well, I don't know a lot of this, but I don't know.
I stuck that vocabulary on there because that's something we need to know. Anybody in this class going on retreat?
I'm going next month.
Brandon Kidd's going on
Okay.
retreat. Charlotte's going on retreat. Claudia's going on retreat. Okay, listen, you guys going on retreat. Next week, you'll miss the test on Friday, obviously. Next week is a short week because we don't have school on Tuesday. So you'll need to make up the test either Monday morning, Thursday morning, or Friday morning.
Why don't we have school on Tuesday?
Same
Yes.
pattern.
And I have a meeting on Wednesday morning. So now listen, the reason I'm saying this is, some of you are probably leaving early on spring break.
Yep.
Keep that in mind because that even lessens your options.
Spring break.
So your options for makeup are Monday morning, Thursday morning, and Friday morning. That's it.
This Friday.
So think
Like
ahead,
3 days from now?
That's in 3 days from now.
plan ahead.
No, next Friday.
Oh,
We have a test this Friday.
Oh, yeah. I thought you said that.
Stop it, you're both lying.
You already did number 3, got parallel. I don't know if you're that far
I
yet.
can do number
Oh, do you
two.
want me to do the rest
Do
of
it
it?
then. No, Meredith's gonna do number 2.
You doing Meredith?
No, Noel's gonna do number 1.
Hey, you doing the work?
I want to do number 1 sport.
All right.
Is
Big red,
anybody
blue together,
comfortable
and
enough
mix
with the
purple.
vocab to put the vocab up?
I think I
I know the last one.
I'm ready.
It's filthy.
It's filthy in school.
I
Answer number
know.
1.
I need some kid to come in and wash it for me.
I'll do it. I got 4. I got 4. So I'm pretty sure.
I said I love it. Eighth grade, the end it was classic.
I think the Swire is like 7th grade.
I'll do after this one.
I'm supposed to.
Mine like right here.
All right, dot product, did you get 1? Okay, now that's really important that you got that right, because you needed that number in number 2, didn't you? Dot product equals magnitude times cosine. She got 82.87. Anybody match that? Thank you, Meredith.
I'll
Good
match
work. Timmy said these guys are parallel. Anybody want to have an issue with that, or you think that's okay?
Agree.
I did.
Length is magnitude. Perpendicular, that's our brand new word. Orthogonal. Sum is not.
I tried.
Sum is resultant.
This is for.
Resultant is different than result. So if I were in a good mood, maybe half credit for that since you're in the right ballpark. Now, does anybody in this room have a question about something on the board? Because tomorrow we're going to have a quiz.
Can we go over number 2? That one's still kind of fuzzy.
Dot product equals magnitude times cosine.
And And you just get the magnitude by.
You draw a picture of the angle.
Oh, I didn't do that, sorry. I didn't
Well,
show
you
it.
don't have to, but he put it in the house, so draw a picture of it, over 3 up 2,
Thanks.
and you do the Pythagorean theorem,
Okay,
root 13.
gotcha.
So dot product equals magnitude times
And
cosine.
then when you get with the cosine there, do you just do, you put everything on one side and then multiply cosine?
No, you second cosine. Josh, to find an angle on your calculator, you use the second function. So we second cosine this number, and it will give us that answer. You've done that a million times. You second cosine the fraction, and that gives you the angle that you're looking for.
Okay.
That's what it said on the tweet.
John Rush?
I love you.
Anything else?
I ain't never gonna stop loving you.
Okay, Potter, you want to turn
What was
that
that,
video off, please? And now you have, I guess, 3 minutes